Hello and welcome to TI Codes Club Session 3. Today we are looking at selecting your hardware for your project, particularly looking at the sensor part of hardware. Two main types, sensors and actuators. Next week we look at actuators. This week we focus on sensors, and of course the purpose of sensors is collecting data. My name is Brian Lannon. I'm your host for this event today. Now our speakers are Peter Fox. Good afternoon, Peter.
Afternoon, Brian. How are you?
Going very well, thank you. And Sanjeev Meston, and we will be hearing from Peter first and Sanjeev later on. I will swap across to Peter now. Peter, we can see your screen quite clearly, and it is all with you.
Thank you, Brian. Today, we're talking about sensors. So if you've participated in our previous webinars, you've already seen how to enter the TI Codes competition and an engineering session where we've looked at how to actually build stuff. And then the third session was on choosing your languages, as in whether you want to use BASIC or Python. And in this session, we're focusing on the actual sensors that you can connect into the TI-Innovator hub. So it doesn't matter whether you're using Python or BASIC to do your programming. It doesn't disadvantage you or advantage you in either way. It's just whichever one that you're most comfortable with. For me, I'm more experienced with BASIC, so I'm going to be doing the BASIC content. Sanjeev's had a few technical issues, but hopefully he'll be able to join us later to cover the Python section. But if not, I can point to the website where you can find these details anyway on how to do the Python section. But the concept and the actual coding is very, very similar. So no big deal. If we miss that, we can point it straight to the website to help you out. So we're looking at three different ways to get data in, three different places where these sensors might be. The first one is a brightness sensor actually on board the TI-Innovator hub. Now that's the easiest one. It's a good one to start with so you get the general idea on how to get information from the outside world into your calculator. The second one is a plug-in sensor. Now, unlike USB ports where things are automatically identified, this has been done on purpose that you plug the sensor in, but you still have to tell TI-Innovator and the calculator what's been plugged in and where it's plugged in to. But nevertheless, most of the other background stuff is taken care of for you. So they're very easy to use, and then you have access to a huge range of sensors. However, if you want to go one step further, on the front of your TI-Innovator hub, there's also some breadboard inputs and outputs. There's 10 of them which you can specify as being a combination of analog, digital inputs or outputs. So we're going to set one up as an output, but we're also going to send one up as an input. Well, I kind of need to do both because I'm going to use the Innovator hub to supply some power to a sensor and then get information back from that sensor, what it's doing or how it's being manipulated in the outside world. So let's start with the easiest one, and that's the brightness sensor. That's the one that's on board. You can see in the picture there, it says brightness, then I2C and data. Well, the data one is the one that's plugged into my calculator or computer in this case, so you can see it. And we're going to see how to address this brightness sensor and what it can do. Now, the screenshot you see there, almost all of that has been covered in the previous sessions. That is things about loops, how to display information, and how to store it. So if you're not sure, you can either check out the TI code section, or you can check out our webinar on BASIC versus Python programming for the TI Codes Club. So what we're focusing on in this session is this command that says send, read brightness. There's another little one underneath, which is get, but that's a normal command that's on it, and we'll see how that's used as well. So let's swap across to the software so you can see exactly how this works. I've called the program Light, The first thing says just how many samples would you like to collect. That may or may not be part of your final program. I've created a list that I'm going to store the values in. That assumes, of course, you're going to store them. You don't have to store them. You might just make a decision and then off you go. So this is the command that we're looking at here. Send read brightness. Now it's important that the stuff in the quotation marks is exactly how it appears. That stuff is case sensitive. And there's a section on our website that tells you how to do all of those things. But you can also, and I'm just going to repeat that command, you can also just use the calculator to pick it up. And that's the way I'd be doing it, so you get it absolutely correct. So I'll press the menu key, and option number 8 leads us to the hub. And you can see we can set something that's important for next week, where we're looking at actuators, or you can read something, which is what we're doing. We're reading something external. And you can see the first option is brightness, which is what's written on the TI-Innovator hub. So we're actually addressing that particular sensor. And that's it. It's now read that information. That's the entire command. Don't need to do anything else. Now I've already got that on there, so I'll delete that version of it. This get section, basically what it means is the value is stored on the Innovator hub for the brightness, and then you need to go and retrieve it. So you can call that variable anything you like. It doesn't have to be B. It's just that's where I'm storing it. You could call it Z. Just that doesn't make much sense if you're talking about brightness, storing it in Z. But anyway, and then this display command. So let's run it and see what it looks like. So it says ready to run, and I'll take up 100 samples and press enter. And you can see I'm just going to put my finger over the sensor. You can see it changes brightness. I can tilt it, get a bit more light on it, block off the light, and so on. And that's it. It's taken 100 samples. Now those samples, if you had a stopwatch handy, that would have all taken place in about 10 seconds. It's taking about 10 samples per second on average. It depends on how much other code is sitting in there. And I stored it, remember, in a variable. So let's insert a data and statistics application, and you can see a myriad of dots there. So I'll just press tab and press enter, and there's a whole smattering of brightnesses that it's done. Now the thing that's missing here is some sort of a timeline. We often want to do time series. So you might want to add a variable that overlays time onto this. And whether time is, I shouldn't say absolute, but if time is actually measured in seconds, you'll need to do a bit more work there to figure out how to make sure that the measurement took place on that particular second. Otherwise, it's just an arbitrary line that you're placing it on, not necessarily aligned to seconds. So that's our brightness sensor. I'll just check with Brian. Does any questions popped in there, Brian, or are we good to keep going?
No questions as yet, Peter. In fact, I was just writing as you spoke into the chat to advise people that if they do have any questions, please type into the chat. That's the speech bubble at the bottom right of your screen. And to address those to all panelists, please.
Thank you. All right, while Brian was talking there, you might have noticed I'm now looking at the side of the TI-Innovator hub, and we can see it says in 1, in 2, and in 3. That's in, not natural logarithm. So we've got input 1, input 2, and notice input 3 has its own little surround there. So that can handle sensors up to 5 volts, whereas input 1 and 2 only go up to 3.3 volts. So that's our sensing. But these are all plug-in ones. Now, the other thing you'll notice is, and I'll direct you onto the TI website shortly and show you where to find all of the specifications, not all sensors plug into all ports and vice versa. But this temperature sensor, that can go straight into input port number 1. So you need to know where you've plugged it in. You'll recall earlier on I said these are not USB, so it's not auto identification. So let's see how that works. Here's a screenshot of another program which I'm about to use. Excuse me. And it says in the first section of the program, it says send connect temperature 1 to in 1. So the in 1 refers to input port number 1. So we need to tell the calculator and TI-Innovator where we're connecting. And we've also said we're connecting a temperature probe. So that pushes through a whole lot of code in the Innovator so that it knows what's connected and obviously where it's connected to. And again, the rest of it's pretty much the same as we had before. I'm requesting the number of samples. This time I'm superimposing some time because we often use that when we're talking about temperature changes. And you can see we've still got this send read, but this time there's this extra little tag on the end of it. It's not just read brightness. It's read temperature 1. That's because I said send connect temperature 1. You give it a number because you might have 3 temperature probes. So in other words, if I had 3 temperature probes, because I'm measuring them at different spaces or different things that I'm measuring, then I would say send read temperature 1, send read temperature 2, send read temperature 3, so that I can address which one I'm referring to and which port that it's plugged into. The 1 and the 1 are just a sensible alignment. Why would you say connect temperature 3 to input port number 1? You are only going to confuse yourself. So let's have a look. There's the little web URL, and this we can make this PowerPoint available to people that are watching the webinar. So our first line, which is the send connect temperature 1, we'll see where that is. You don't have to type it, but remember before I said the capitalization, everything in those quotation marks is important. So I haven't typed it just so that it looks impressive. It has to be written that way. And then our other command down here, read temperature 1. Okay, so let's cross over to the calculator. I put this as problem number 2. So there's the program that we have in the screenshot. Let's see where this send connect command can be found. So menu, it makes sense. It would be talking about the Innovator Hub. So that's menu 8. Just skip back, it jumped. And you can see option 8 says send connect output. No, we want an input. And I'll select that one. And you can see the range of sensors that are automatically defined for our TI-Innovator Hub to use. So the one we're using is option number 4, the temperature one. And as you can see, it's already started to populate that command. But how do I know what's next? All right, so for that, I'm going to jump across to the TI website. Bit of advertising for our upcoming sports webinar. But
I'm looking forward to that one. Yep.
Yeah. So here we are in the online tool. Now I'm looking at temperature. Now you can see this one says read DHT temperature. That's actually a different probe. So I'm just going to type in temperature. And you can see it says temperature sensor, the very first one. And there's a picture of what I'm using. So that's kind of handy. And it says that you can connect this sensor into input port 1, 2, or 3. So make sure you read that. And it tells you the operating temperatures. And for programming purposes, it also tells us some syntax. So you can see here it says connect, and it's highlighting the word temperature because that's what I search for. Temperature 1 to input port number 1. And this is a real generalized thing. So that's just labeling. The first one is telling us, give it a label. And then where did I connect it to? I connect it to input port number 1. That's it. You'll see it also gives us the syntax for the read command, which we saw before. So this online tool is very handy whenever you want to look up the syntax for one of the commands. Now, if you're wondering where to get that from, obviously you can get it from our webinar. But when I go on to the TI Australia webpage, if I just go down to TI-Innovator Hub, it jumps here and says these are the things that are associated with the TI-Innovator Hub, the rover or the TI Launchpad board. That's the one I want. And there's some information about it. And I want some resources. So I'll have a look at the resources. And you can download a PDF if you don't have access to the internet. well, obviously you need it to download the PDF, but if you're working with it in class, you might just have a PDF available. But I find the e-guide is very useful. It's loading up on another tab because I can just hit search. And that's what I did before. So I searched temperature. Probably need to spell it correctly. And there it is again, the temperature sensor with a picture and all of the details.
Yeah,
So let's
Foxy,
see what.
I'm just thinking. Perhaps we should point out there that was on the USA Canada website that you were showing.
Yeah, that's right, because it's common to everyone.
Yeah, that's right, but it's all linked from our TI Australia site.
Correct.
Yep.
So you don't have to change your location. You don't have to get on a plane and go over there. You just click and you get there. No COVID test required, right? So let's run that one and see what happens. Now I'm going to put my hand on the actual sensor, which I've got a couple of them plugged in, so I better make sure I grab a hold of the right one, and we'll run it. And let's take, say, 100 samples. And you can see now that I'm touching, you can see the sensor's starting to warm up. I'm obviously a bit cold at 28 degrees skin temperature. I'm getting back up there, I guess. So it's taken, well, whatever it was, 100 readings, I think I saw. And this time I collected time. Now, remembering time is not measured in seconds here. It's measured in, how many samples it can do. So let's just do insert data and statistics. Press tab, we'll do time down here, and press tab, and we'll do temperature up here. And there's our funny little temperature graph. You can see it's kind of a curve. So for 100 readings, my temperature on the sensor went from 24 degrees up to about 28.5. And it's also important, you can see here, it toggles a little bit, 28.6, 28.5. Now I was holding on to it the whole time, and yet it jumps about. So it gives you an idea of error margin. So we're seeing about a 0.1 degree difference it can sort of jump around on. So just remember that when you're writing up an experiment that might be using this stuff, is that there's about a 0.1 degree variation. But if you think back to an old analog one, or particularly the old alcohol-filled ones, the one with a red bar on it, it's pretty hard to read 0.1 of a degree sensitivity. So I'm reasonably happy with that. So that's our temperature sensor. Let's go back to the slides. Pretty straightforward. Let's have a look at some other ones. So this one, because you're not limited to having one sensor plugged in at a time. So this one has a Hall effect. And for those not sure what Hall effect means, it's basically detecting a magnet. So it's going to detect the presence of a magnet. And then I've got another one which is called DHT. The D is for joule, H is for humidity, and T is for temperature. So that probe, one single probe, is capable of measuring two things at once, humidity and temperature. But there's a limit. That particular probe gets plugged into input port number 2. So if you get an error, it's not working properly, it could be because you assigned it to input port number 1. Now the website that I showed you before, let's jump back to that, and we'll do a DHT. And let's have a look at the information. So it's giving us some information here. And it tells us the sensor, humidity sensor, and as you read through, you can see you can either address the temperature separately, the humidity separately, or you can get both readings at once, returned from the sensor. We haven't got a picture there, so you might want to look at some of the other links because you will eventually find one that has a picture of this particular sensor. Nevertheless, we're good to run it. So let's go back to the program and have a bit more of a closer look in at the program. So I've got this magnetic reed switch or Hall effect sensor, which I've called magnetic 1. I've plugged that into input number 3 because my temperature one is still plugged into number 1. I've connected this dual one into input port number 2. Again, just the same thing as what I had before. This time I'm collecting humidity and magnetism. Well, the magnetic switch. You'll see what it does in a moment. And I've put some extra stuff down below, which we'll have a look at in a minute. But you can see that this particular sensor has a slightly different send command than the magnetic read one. So this send command, you can add on, as it said on the website, humidity or temperature. If I leave that off, it returns both at once in a list. So you have to be careful what you're doing there. That would automatically turn variable H into a list. So let's see what happens when I run it this time. Humidity, temperature. Now I have a little magnet next to me. Let's see if I can get that Hall effect one working so you get the idea. How many samples? Let's take 60. That will do. You can see the humidity in my office here is 59. The switch is now closed. I call it a door. The switch is open and I'll put the magnet back on it. It says it's closed. So you can see all it's doing is opening and closing. Now that's not the value that it returns. Let's go back to the program so you can see what it's actually doing. This read actually returns a 0 or a 1. That's it. It's binary. So I said if it's 1, then say that the switch is closed. Otherwise, say that the door is open. So it's just displaying at line 2 door, and then it returns the value open or closed. If you're writing that in your code, then you just say if S equals 1 or if S equals 2 or whatever else you wanted to call it. And there's our humidity. So it's doing both. I could add on the temperature one. Interesting to check the temperature through the humidity sensor and the individual temperature sensor. Now, I understand Sanjeev's managed to join us. I might as well just finish off what I've got here, Brian, before we change over to Sanjeev.
Yep, all good.
Well. Yep, sorry, go on.
Oh, I was just saying, yep, going well. And we've also had more participants arrive during the course of the session.
Well, that's good.
So I'll just again point out for those who have joined us at a later point that all sessions are recorded, and you can find the recordings both from the TI Australia website or from our YouTube channel.
All right, so as I said before, and also I guess for those that didn't hear because they weren't on board yet, is that the sensors, some of them have to be attached to a specific port. So always good to check either the manual or check online to see through that electronic guide. Now, the last one I'm covering here is a breadboard input. Why would you want to use a breadboard instead of a sensor when the sensors are so easy to connect up? Well, basically it means that you can introduce sensors that have not already been programmed to be used by the TI-Innovator Hub. Anything that uses electricity, basically. We can check it and read it. So there's a little breadboard pack you can buy. So that's the little breadboard essentially that comes with it. I've got a little variable resistor attached. I use that same one in the engineering project. And the first thing we do is connect a negative or earth to one side, and then I'll connect the positive to the other side. So this gives me a reference voltage. So I'm actually using breadboard port 1 as an output just to supply voltage. Now I could have supplied it from an external circuit. I'm keeping it simple. And then I'm just going to read into breadboard port number 5. So I'm going to make that one an input. Now you'll notice I haven't had to connect up an earth. That's because we've already earthed this. They're all connected. So what does the program look like? Let's have a look. You'll see the program's a little bit more complicated, but not too bad. I've sent a digital out to breadboard 1. Digital because I'm only interested in it being on or off. So 0 volts or 5 volts if you like. And then I've sent a connect analog. And that's my reading one. And I've said that is an input on port 5 or breadboard port 5. And in that third line, I've said set the digital output to 1. So in this case, I just want that on. Then I can take my readings. I've got it set for 500 readings there. I might just change that before I run it. So what does that program look like? There it is there. I didn't do a request for how many readings this time. So I'll just do the 100 readings. So it's going to get V, which I've called a voltage. And it's just reading the analog. But again, menu, hub, and read. And you'll see down at number 9, analog in, you can read a digital in, and so on. It means we get access to sensors that you don't have in that list there. All right, so let's run it and see what I get. Now, the variable resistor is on that circuit board, so I'll run the program and I'll just dial up the variable resistor. So we started off on about 13,000 or 15,000 there, and I'll probably get it down to 0 before it stops. There it goes, and I'll just wind him back up. So as you can see, you can just read in basically a number, which you will then convert to some sort of a voltage or some measurement that you want to use in your experiment. So that's it for the basic on breadboards, sensors for the input ports, and also the onboard one. So let's throw over to Sanjeev, who will do us some work, same sort of stuff, but with Python.
Yeah, that's really interesting there, Peter. I find the breadboard is extremely powerful because really once you've connected to a breadboard, that brings in the possibility of running transistors and MOSFETs and even relays. And once you're into that area, you can really the sky's the limit. You can drive anything.
That's it. And the only other thing you've got to watch then is you need to know a little bit about parallel and series circuits, potential dividers, Ohm's law, some very basic stuff. But yeah, most people can get all of that from their physics teacher or their science teacher. But right now I can see Sanjeev's screen, and I'm guessing he's already set up our first one, which looks like the brightness one.
Yes, it is. Hello, Sanjeev.
Hi, Peter, and welcome everyone. Sorry, I was slightly late in joining the webinar, but we're all good. So Peter would have demonstrated the onboard sensors. So I've got actually an onboard sensor on the Innovator hub, which measures the brightness of light. So in Python, I showed you how to add a Python program. So the first thing that you would be doing is you will go and import the hub module. That's the hub module there. The next thing that I have done over there, and of course, I'm just going to show you how to get the brightness bit. So if I go to menu and if I go to the hub module and hub built-in devices, and right at the bottom, you see the brightness input. So one is the measurement and number 2 is the range. So I'll just click on that. Of course, I'm not going to add a range because I've already added that. But when you see brightness range, I've set it from 10 to 50. You can actually have any range. So I'll get rid of that part there. And then I'm running a loop over here. Now, my next program will demonstrate a while loop, but in this case, I'm just running it with a for loop, and I'm saying I'm going to run 11 iterations. So in Python, as I said, if it'll start with 1, but it will go up to number 12, but that would actually mean 11 iterations. So it doesn't go to a 12th one, it stops at 1. And I've put a sleep command over there. That means it's going to record the brightness after every 1 second. And then I'm saying print the brightness each time. Now you will see this print command is within the for command over here. So at every stage, it is going to print the brightness. It's going to measure it and run that. So let's run this program. So Control R, and it should, you can see it's recording and it's picking up the brightness. And obviously I'm in a room where the brightness is pretty much constant, but if I can change the brightness, you would see that. So it's picked up the readings over there. So that's the onboard sensor over there. And you would see I put my print command within the for loop, so it's printing at each stage. At this stage, I haven't saved any of these. So next, what I'm going to demonstrate is how could I save this as a list. So let's look at the next program that I've got over here. And this time I'm going to use the external connections for the sensor. So I'll just turn my camera on and I'll just show you. 1 second. I need to go. Just minimize that. Yeah. Where's my start video? Yeah. Okay. So I'll just quickly show you. That's the Innovator hub, and I've got 2 sensors there, and I've connected them to in 1 and in 3. So if you're able to see that, let's see if I can make that bigger. No, it doesn't. Yeah, that's the bit. So I'm guessing you're actually seeing the full screen. So I've connected 2 of them, and here are the 2 sensors. So the one which has a LED, like the LED, that's the brightness sensor, and this other one here now that I'm showing is the temperature sensor. So I've got 2 sensors. So the temperature one is connected to input 1, as you can see on the screen, and the light sensor is connected to input 2. And I have stored them or defined them as variables. So temperature T and the light by the letter L. Okay, and once again, like I did previously, I've assigned a range for the light, and I've gone from 0 to 50. So coming back to the program, get rid of the video. So yeah, here I've created an empty list. Now in Python, the empty list goes in square brackets. Unlike basic and the TI-nspire, where the list actually goes in the curly braces, here it goes in square brackets. So there's an empty list which has no data at the moment, and I've called that temperature. Likewise, I've got another empty list which is called brightness. And I'm using a while command this time. Of course, I could set a condition. It could be if the temperature is less than this or whatever condition could be set, but I've actually set a very simple condition. I'm saying if the value of I is between 4 and 12, and at the moment I've put I as 4, I could actually put 0 or 1. And if I put I as 0, it won't run the command because the value is outside the range. And then each time it's saying step up the value of M by 1. So I'm not saying, if the temperature becomes this, stop the loop or whatever. I just put a simple loop. And what that says is if I'm starting with M as 4, next time it will go to 5, 6. So it's very similar to a for loop, what I have done. So going back over here, I'm recording the temperature and the brightness after half a second. Instead of 1 second, I've made it 0.5. And I'm saying temperature is, now I just want to show you this part. So I'm saying, let's record a reading, and I'm saying is equal to, and the moment I put T and dot, you will see it comes up with the measurement option automatically in Python. So I've already put that command over there. So it's going to record that for me. So I'll get rid of that line there. And I'm saying append this to the empty list initially. So this TEM that I have created is being added to the list. So in Python, append to list is adding to the existing list. So my existing list was empty. The first time it runs the loop, it will add the first measure for temperature, and it will do the same for light. You can see I've repeated the command over there. Now down here, I have actually grayed out the print command for temperature and brightness, but I'm actually going to enable that by doing Control T, and I'll show you the difference there. So Control T. So both are enabled there. Okay. And then this is the graphing part. I'll come back to the graphing part in a moment, but I'm actually taking this data and doing a plot. So let's just run the first part. So I'm running the code now, and hopefully, because I've got the buffer on, you'll see actually it's done a graph as well as of the plot. And if I click escape, you will see it's got all my readings there. Now, it's got the list as a horizontal list, and later on I'll show I've got them as vertical. So the first column here is all the temperatures, and the second column is the brightness of light. So if I go back to my code here, now I can disable these two. So if I do Control T, I've disabled the print command over there. I'll just explain what the graphing part is. So I've imported the TI plot library, and I've set a plot color, and that's in RGB. So I've just, probably there'll be more of red in this. And I've set the window size as auto. Now that's the good thing about Python. It will look at the data and it will size up the window accordingly. So I'm saying plot with the auto window and take the temperature on X-axis and brightness on the Y-axis. And I'm saying show the axis as well. So the axis are on, and we are doing, let's go and do the plot. And I'm plotting temperature and brightness, and I'm using dots. So you can use crosses, dots, or circles, whatever there. And that's going to do my graph. And right at the bottom, I'm saying, okay, I want to display the items. Now, this time I'm displaying them vertically rather than horizontally. And I've combined the two lists. And in Python, you have a zip command. So I said list of lists. So the temperature and brightness were taken together. And then I'm saying go and put them together and then print the temperature. So I'm running a loop over there. So for temperature. So it's going to pick up the items from temperature and just do a count, and it will take the corresponding value of the brightness. So let's run this now. So it's running, and you'll see I've actually used plot buffer. That's what. So it's done this graph and it's taken all the points, and effectively temperature is increasing, decreasing. That's why you're seeing the points going forward, backward, and so on. But if I was actually, if I had a light globe where the light is got, the globe has some heat, and if I move my sensors close to it, the temperature would go up and the brightness would go up, and you'll actually see a wonderful graph there. But Python does this graph for me. And now if I click escape, once I'm here, it gives me all my readings there. So the first column is temperature and the second column there is the brightness. Let's go and look at another program which is very similar. So it's essentially the same program. I've got in one for temperature and in two for that. The only thing that I've changed over here, I've still got the sleep as 0.5. Everything still remains the same. I've still got the graph. You'll see I've actually used a different method this time of joining the lists. And I've used the format command, and then I'm saying store that as result. So everything effectively is same as what I did previously, except I'm saying print the result. Now, once it does the graph, it will stay on the graph screen as you noticed until I click the escape key, and then it will take me back to my two lists. So I'm going to run this command over here, or the code, and it's running there. So it's running in the background, and that's the graph it's given me this time, and you can see the list now. When I did this formatting, I've actually created a space over here. Now I could do a float to 3 decimal places, 2 decimal places. I could include that in my command as well. I haven't included any of those, but I could potentially do that. If I can take you back here. Or probably if I go to this one here, I just will do a Control T there and show you what happens now. Okay, it says plot use buffer. And I've just run the command. And probably I have to maybe import a module. It basically has done the same thing. But when you put the buffer, actually it runs the command, it stores everything in the memory and displays everything at one go, rather than doing step by step. So at times you don't want to kind of see live readings, then you can use the buffer option there. So I think that's really it from me, unless you have some questions, or Peter or Brian, do you want me to display anything else?
That's looking very good. Thank you, Sanjeev. And it's interesting that you've both sort of gone over similar sensors there. And what we're able to compare here is the two different coding languages, whether that be TI Basic or Python. I have run a live poll just in the background, and interestingly, it's about even, which the attendees today. So both of these coding languages are popular in our TI Codes Club. So it's I think it's terrific that we've got Peter demonstrating the sensors on TI Basic, and yourself, Sanjeev, showing us the same, pretty much the same sort of thing, using Python. So I don't see any last minute questions here in the chat, but if you wish to do so, now's your time to type questions into the chat. I will transfer the meeting back to myself and just close
Just while
this
you're
out.
doing that, Brian, the Python shell, the way it prints the graph is really nice. I do like that. There's a bit more work if people want to use the drawing canvas in TI Basic. You can do something similar, but I do like the fact that Python does it pretty much seamlessly, doesn't it, Sanjeev?
Yeah,
Sanjeev disappeared.
yeah, Sanjeev had muted his mic there, but yes, it works quite smoothly in the Python, and I do know that a lot of people prefer to use Python, for that being one of the reasons. Someone's just asking, can the axes be labeled in the Python graph?
Yes, it can be.
Great. Yeah. Okay. I'll just point out that I'm hoping that if you've looked in your support guide for the competition, the reference guide, that there is, I think it's on page 4, the list of some sensors and actuators from the what's called the I/O pack. So that's the materials that'll be provided if you get through to the next stage of the competition and you wish to use these. There is an Innovator input-output module pack. Now these are the things that are contained in that. So input, of course, being sensors and output being actuators. Of course, once you go to the breadboard, there's a whole lot more that you can work with in that. And as I said before, the sky's the limit once you get into using the breadboard. So these are two other products that can be useful for your project. Closing our meeting for today, I'll once again express thank you to both of our presenters. Thank you to you, Peter, and to you, Sanjeev.
Thanks, Brian.
Thanks, Brian.
And we look forward to seeing you again next week when we basically look at the same sort of thing, but that time we will be focusing on actuators. And of course, ultimately, that's the thing that you'll be ultimately wanting from your project for enabling it to actually do something. So all the very best. We can hope that you can join us again then, same time next week. Cheers now.